Hello everyone, welcome back to EGR 250. Today we're going to be going over another example problem. This one right here. And also just want to let you know I'm being joined by my beloved younger son. So if you hear some cooing in the background or occasional cry, it is not me, it is a baby. Okay, now this one asks, what is the internal force in FG and kips? Now this is a pretty big beam. We could solve it with the method of joints, or we can solve it with the method of sections. There's two ways to do it. I'm going to show you both. Now the first step in either case is always a free body diagram right here. If I make a baby voice, that's because I'm talking to a baby, not to you. So that is AX right there. That's AY. I'm going to make my little pin a bit heavier. There we go. That looks nicer. Let's try again here. So I've got AX here, AY here, AY, AX, and I've got EX right here, or sorry, EY right here. Now before I go anywhere, I want to solve for these reaction forces. There are forces. And to do this, I have three equations. Some of the forces in the X, some of the forces in the Y, and some of the moments about some arbitrary point. Usually it's either E or A in this case. It's the points that you have unknowns at. Usually it's one of those. So let's start with some of the forces in the X. We know this is equal to 0. And if I look, I only have one force in the X direction. So WAX, and therefore AX is equal to 0. That means I can go ahead and get rid of that. Get rid of that entirely. Boom, 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 boom. Okay, so AX is gone. Now let's do some of the moments. I'm going to show some of the forces. I'm going to do it blind. And so I've got two forces going up. That's AY and EY. And I have three forces coming down. So minus 10, minus 40, minus 10. And that will all be equal to 0. Nada. Always 0. Okay. But with that, you can see that I can't actually solve that equation. I've got two unknowns, one equation. And so what it gives me, though, is AY plus EY is equal to 60. 60 kips. And now I'm going to use my last equation. I'm going to take some moments about, I can choose either A, E, or any of the other points I want, but I'm going to choose A to make things a little bit simpler. And so that's equal to all the forces times all the distances, perpendicular distance. So I have 10 kips times 20. So 10 times 20. And so since I've done that, I guess I'm making clockwise positive. Plus 40 kips times 40. Plus 10 kips times 60. And that's going to be minus EY times 80. And that's going to equal 0. Okay. Now, if I solve both these equations, I'm not going to take the time to do that right now. What I'm going to find out is that EY equals 30 kips and AY equals 30 kips. That's just some basic algebra. I solve for EY first, and then I solve for AY. Okay, so I'm going to go ahead and replace those numbers right here. And this is already enough to solve my problem. Like, I don't actually have to do too much more to solve it. Okay. Now that I've gone to here, I have two methods to solve this. I can use either method of sections or method of joints. I'm going to show you both. Also, if you need more time to write all this stuff down, please go ahead and do so, because I'm about to erase the work just so I have more space. Okay, so I've given you time. Hopefully you've written it down. You can always pause if you need more. And this is all gone. Now I want the force right here. So we're going to use the method of sections first. Method of sections, I cut my beam. Hi-ya! I'm a ninja. And after I've cut my beam, I get rid of half of it. Well, I'm going to get rid of the bigger half. And all that stuff I got rid of, it no longer exists. It is gone. It is kaput. It no longer has any meaning. And I redraw it. So I'm going to redraw my beam. It looks something like this. And wherever I cut a beam, I just replace it with a force. Okay, something like this. And I have the 10 kips still here. I have the 30 kips here. I have force FG, which is what I want to find. I have force BG right here, which I don't really care about. And force BC right here, which I also don't care about. With method of sections, you get 3 more equations. I get some of the forces in the X, some of the forces in the Y, and finally, some of the moments about an arbitrary point. Remember that some of the moments is usually the most helpful, especially with method of sections, and especially in this particular problem. Because if a force goes through the point you take some moments around, then all those forces do nothing. So I'm going to take some moments right here, because that gets rid of this guy, and this guy. Which makes it much easier on myself. So, some moments about point B. And I could have chosen any arbitrary moment. I could have solved it. I have 1, 2, 3 unknowns. I have 3 equations. So, no matter what, you could have solved this. It'd just be more algebra. Getting good at using these problems is just usually learning how to avoid the algebra. Okay, so forces times distance. So I'm going to do the 30 kips. And that's going to be times a distance of 20 feet. Minus force Fg times 20 feet. That's equal to 0, and you might be able to guess that force Fg is therefore equal to 30 kip. And there you have it. Okay, now that's method of sections, and that worked really easily here. It's not always the easiest, but it is often the easiest way to do things. Now let's look at the method of joints. Okay, so let's erase this. We're going to keep on going to the method of joints and figure out how to solve it that way. Ooh, my computer's running a little bit slow today. Okay. And we've cleaned everything off. I'm going to still, I'm not going to do the initial setup again, so still 30 kips for both ends. Now, method of joints is I choose a particular point, in this case A, and I redraw it. And it has 2 forces coming out from it. It has force AB, which we don't know. And it has force AF, which we don't know. And we know that there's a 30 kip force going up. With a method of joints, whenever you're looking at just a point, no size here, we only get 2 equations. We get some of the forces in the X and some of the forces in the Y. X and some of the forces in the Y. These are the only 2 equations you get to use. So if I do some of the forces in the X, what I see is that I have force AB, and I'm doing my slope triangle here. Let's see, my slope triangle looks something like this. It's 1, 1, because it was 20 and 20, I just divided by 20. And then this right here will be the square root of 2. So, with that in mind, it's not too bad. It's force AB, 1 over square root of 2, plus force AF. We know that's equal to 0. But we can't solve that, though. I mean, that doesn't really work for us. So let's try the second equation. Well, it's still force AB, 1 over square root of 2, and plus 30 kips. Okay, this we can solve. This we can solve. So if I do that, what I get is that force AB is equal to, it'll be negative 30 square root of 2 kips. Negative sign means that I drew my arrow in the wrong direction. It means it's in compression. Just always draw your arrows going away from the points, and if it's negative, compression. Negative equals compression. Okay, now we can plug that back into our original equation. So I'm going to take this and stick it in here. And if you're wondering why I didn't simplify, it's because, and then it makes it a lot simpler. Because what I have then is negative 30 square root of 2 over square root of 2. Notice the symmetry there. Plus force AF equals 0. Therefore, force AF is equal to 30 kips. Okay, so we solved that point. Now we can move 1 point closer. We were here. Sorry, kind of went too far there. And now let's move to this point because it has all the forces we care about. Sound good? Hopefully, because we're going to do it. So I'm going to redraw this point. I have this point right here. I have a force right here, which is force FB. We don't care about that. Force right here, which is force FG, which we do care about. And a force right here, which is 30 kips. Okay. Once again, we have some of the forces in the X and some of the forces in the Y. And what's super easy to see here is there's only 2 forces going in the X direction. This guy and this guy. And therefore, force FG is equal to 30 kips. Boom. Done. Finito. So this one required a little bit more algebra. You're going to have to do a slope triangle, but sometimes it's simpler. It just depends on the problem. So once again, I hope this example helped you. We were using the method of sections and the method of joints, and I will see all of you next time. So with that, have a good day. Goodbye.